I'm going with my VOG. Ladies and gentlemen, please welcome Anders Heilsberg.
Thank you. Thank you. Thanks. Thanks, everyone, and welcome also to the folks watching online on Channel 9. My name is Anders Heilsberg. I'm a technical fellow in the developer division at Microsoft, where I work on C# and also on a project called TypeScript, which I work on with a fellow also named Steve Luco, who's here, and he'll join me for Q&A after the talk. So TypeScript sort of got its birth as the answer to some feedback that we've gotten increasingly over the last 5 years, which is that people are finding it very hard to write large applications in JavaScript. We hear this both internally and externally. There are several reasons. Probably a main one is that JavaScript was really never engineered to be an application scale programming language. We're now, it was mostly intended for 100-line apps, and now we're with regularity writing 100,000-line apps, and things are straining a bit. Part of the problem is that JavaScript doesn't have any large-scale application structuring concepts in it. There are no classes, no modules, no ability to define interfaces. And also, it's an entirely dynamic language, which is great when you're writing small stuff. But as applications get larger, things like optional static types really can help tremendously. If you think about what it is that has powered the revolution that we've seen in intelligent development environments over the last 10 years, most of the power, certainly when it comes to the languages, comes from static typing. The ability to say, find all references, refactor, go to definition, get compile time verification before you deploy your code and whatever, is just priceless when it comes to large-scale apps. So 2-3 years ago, when we were thinking about where to go next with our JavaScript development tools, we thought, wouldn't it be great if we could somehow strengthen JavaScript with these things that are missing for application scale development, but do so in a way that doesn't mess with the sort of core value proposition of JavaScript, the open standards, web, and cross-platform, the ability to run everywhere. And basically, TypeScript is that. TypeScript is if you will, the marketing line, a language for application-scale JavaScript development. Sort of a little more technically, TypeScript is a typed superset of JavaScript that compiles to plain JavaScript. And the compiler, the code it produces, runs on any browser, on any host, on any OS. And the entire project is open source, and we've been doing all of our development in the open for the last 9 months or so. So TypeScript starts with JavaScript. In a sense, all JavaScript is valid TypeScript code. You can just rename your JavaScript files to .ts, and you'll probably see a bunch of errors that our type checker picks up, and now you can sort of go ahead and add type annotations, modify your code, and so forth. All JavaScript libraries work with TypeScript because we are just a superset of JavaScript. So frameworks that are out there, and there are many, like Node, Backbone, Knockout, Express, etc., all work with TypeScript. And if you add static type annotations, they work even better with TypeScript. And the thing TypeScript adds, if you will, on top then is optional static types, classes, and modules. And those are really sort of the key drivers behind excellent tooling that we can build on top. But the cool thing about it is that there's really no cost associated with this. All of what TypeScript provides, it provides at development time. Once you compile your code, you're left with plain JavaScript that runs anywhere, in any browser, on any host, on any OS. And indeed, the JavaScript we generate, I call it here idiomatic JavaScript. We actually, as a mantra on the team, has sort of strived to produce pretty code. You know, we're never trying to like produce big mangled output or whatever. We try to produce really nice looking JavaScript. So if you were to get tired of TypeScript, you could just take the compiled JavaScript and go on your merry way and continue developing that. So that's sort of in a nutshell what TypeScript is. If I could have my machine up here. I'm going to spend a substantial portion of the talk here just demoing the product so we can see it in action. What I have here is Visual Studio, and I've downloaded the TypeScript 0.9.0 release that we put out about a week ago. As I said, we've been out for about 8 months, since October of last year, and 0.9.0 is the latest release on our march towards 1.0, hopefully later this year. So, as I said, TypeScript is basically starts with JavaScript, and I could just take a piece of JavaScript code here, a little function, and paste it in, and here I'm looking at JavaScript in a TypeScript file. Now, there are no type annotations or anything in this code, and if I start hovering over things like, for this is a function that sorts an array, by the way, makes a copy of the array, sorts it, and returns it. Now, if I hover over the argument A here, you'll see that we don't know anything about what type this is supposed to be, so we tell you that it can be of any type. And we've also inferred that the function returns something of any type because we don't know anything about it. If I edit inside the function, you'll see that I don't get statement completion when I press dot because we don't really know what to tell you at this point. And I'm also able to just say sort by name and call it with the number 5, which is, of course, meaningless, but this is valid JavaScript. You can do anything you want in JavaScript, really, right? And actually, our job in TypeScript is in a sense, to tease out the semantic of subset of JavaScript that makes sense. And we do that by allowing you to annotate your code with types. So we're not the first, by the way, to think of the idea of type annotation. Google has a tool called Closure that allows you to put type annotations in comments. So, and it looks something like this, where you say @param, and then you say that A is an array, and you could say other things. But if you think about it, comments are not the best place to host your type system. You know, it's not particularly expressive, and there are lots of things that you can't say in comments that you would like to say. So instead, what TypeScript does is it allows you to put type annotations directly in your code, and then when we compile, we remove the type annotations. But at development time, we pay respect to them and use them in order to analyze what you're doing. So I could, for example, say that A is an array of anything. And now a few things. Well, first of all, if I had kept my sort by name of 5, you'll now see that I get an error down here saying you're passing me something that isn't an array. Also, if I start editing in my code, I say a dot, you'll see that all of a sudden we now get statement completion because we know what all of the methods of array are, and we can show you, and we can help you complete as you're writing your code. We've also inferred other things about the code. If I hover over result, well, because the slice function returns the same type of array as it's given, the result variable we've inferred is an any array, and since we're returning result, we can infer that sort by name returns an any array. So types sort of flow, and so we've inferred a lot already. Now, of course, if you look at a code that's in here, this isn't the full story. We call the built-in sort method on an array here, and sort will call us back then to compare elements of the array. So you see we provide a callback function. And here, x and y, because we've said that it works on any old array, well, x and y are typed as any, and now we don't actually get any completion help in here. And really, as you can tell, this thing obviously is sorting things by their name properties. So maybe we could be even more specific in our description of what this thing does, and we could define an interface called entity with a name property of type string, whoops, like so. And then we could change our array to say it's an array of entities. Now, first of all, what I just declared here is really just a type, and then I gave it the name entity. It's an object type. So I've just described something that has a name property of type string. And then I've said that my sort by name function takes an array of things that have a name property of type string. Now, a couple of things happen. First of all, we see down here that we still have the error. And now, but in here now, because the sort method on an array will present us with two elements, we can infer that the types of the elements are entity, and therefore we can now actually validate the code. And there's obviously something wrong. You can see if I say x dot, we'll see it has a name property. And name is of type string, and so now we can show you all the methods on string, and you'll see that there's a locale compare, but I had accidentally written local compare. This is one of those things you don't find out until you run the code, but with static type checking you do. And so we can correct the code here and write it the right way. So let me just show one of the other things that static typing brings to bear. Let's say that I, for example, also had a local variable name here. And let's say this is a very big code base, thousands of lines, and I'm using entities all over the place, and now I decide this name property, I really want to call it entity name or something else. I can now go and refactor, and so if I say refactor rename, you'll see that the IDE has already highlighted all the places that this thing called name is referenced, but omitted all of the other places where there's an identifier called name that isn't this one. And now I can say, well, call it entity name instead, and you'll see that we rename the property, but not the local variable. And this is one of those things, if you have a 100,000 line JavaScript app, and now you're trying to find all the places where this property is used, and it's maddening. And no one dares change anything. Once you get beyond a certain size, it's just like, it's read-only code. You don't change it. So now, I'm not saying that this is snake oil or this is going to solve all the world's problems, but this at least will let you sleep better at night, knowing that your refactorings are much more likely to work. Okay. Let's try to play with this entity type a little bit here first. I could add, say, another price colon number to my object here. And let's maybe try to declare a variable e of type entity. And now when I say e dot, you'll see that we have name and price, of course. I could also try to write an entity. And now you see that we actually can help you when you're writing an object literal and just give you statement completion on that. So name is, say, it's a hammer, comma, price, $5.95, for example, like so. So a couple of things are worth noting here. Interfaces in languages like, say, C# and Java are nominal. And you only implement an interface if you say so in your class definition. Not so in TypeScript. In TypeScript, interfaces are, or the entire type system actually, is a structural type system. And you implement an interface merely by having the same set of properties that are described in the interface. And so here, because I wrote an object literal that has two fields, name and price, and by the way, it could have other fields like foo, colon, blah, blah, blah. Whoops. And that would be fine. That's still an implementation of the entity interface because it has all of the required members that are described there. So typing is structural, which is actually very handy. I could, for example, add, say, another property in stock colon Boolean. And now you'll see down here that we get an error saying, and we can actually tell you what the problem is here, that you're missing in stock from the entity definition. Now, one thing we can do is we can make this an optional property. So we can use a question mark modifier here to say, in stock is a property that you may or may not specify. But if you do, it must be a Boolean. So in this case here, if I now write in stock, and I say true, things are happy. But if I say in stock and I say 10, for example, then again we get type checking saying, you know, these two are incompatible. And these type declarations of ours, we actually sort of allow you to model all of the things that occur in JavaScript. Let me try and add a couple of methods to my entity. For example, a getName and a setName property. And now if I go implement down here, you'll see that I can actually just write getName as a function, and in here say return this.name. And and setName, function of s. And one thing that's interesting to note here is that if I now press dot on s, you'll note that the type has flowed in, because we know that you're writing an entity. An entity has a setName method that takes a value parameter of type string, and so we can flow the types through your object literal and automatically give type to the parameter s. We know it's a string because we're matching it up against the declarations that you did. So we can complete this guy here and say this.name equals s, for example, like so. Okay, so that's a little bit of what you can do in these type declarations. You can also define function signatures, constructor signatures. Indeed, we can model pretty much everything that happens in the JavaScript type system. And this basically allows you to write down the types that occur in the DOM, in the JavaScript runtime libraries, in frameworks that are out there in the wild. And once you do write that down, or once someone else writes it down for you, all of the tools can light up and give you verification of your program and assistance as you're writing, verification, and so forth. Okay, let's try to take this code that we've been playing with here and move it over to the TypeScript playground. So I'm going to copy it, and then I'm going to switch to the browser. And here I've fired up the TypeScript website and gone to the playground. And I'm going to just paste in the code we were just playing with. Now, the playground is a little website where you can type in TypeScript and see the compiled JavaScript. On the left-hand side, you have TypeScript. On the right-hand side, you have the compiled output that the compiler produces. The interesting thing is this is powered by exactly the same language services that you saw me use in Visual Studio, because the entire TypeScript compiler is written in TypeScript. And when we compile it, we get JavaScript. And that JavaScript will run anywhere, including this browser or on my phone. And so we can actually, you know, set up a complete little mini development environment powered by exactly the same services that we have in Visual Studio. So I'll just continue working with it in here. So one thing you also see is that the compiled output is really the same code, except all the type annotations are gone. You see the interface declaration just evaporates. It's purely a design time artifact. And likewise, the type annotation here is gone. But other than that, we don't actually muck with your code. It's your code, just minus types. Let me try to go back and grab some code here and paste it in here. Let's get ourselves some products, and then let's try out our little sort function here. So we're going to say var sorted equals sort by name. And you see here we get statement completion, sort by name of products. There. And let's say that we then want to like output the result of that. So we'll say document dot. And here you see that we actually get statement completion on everything that's in the HTML or the JavaScript DOM. So document.body.inner text, for example, equals JSON dot stringify of, and then we'll take our sorted, comma null, comma 4. Yes, I know the magic incantation to write here. And now we can try and run it in the playground and see that we actually do get a little JSON document with our product sorted by name. Now, if we look a little more at what's going on here, up here you see that the compiler has inferred that products is an array of objects that have a name, price, and ID property. Now, we can pass that to sort by name because it takes an array of things that have a name property, but the result that comes out then is an entity array because we've actually up here inferred, and I'll just make it explicit here, that sort by name takes an array of entities and returns an array of entities, and that actually means that in our sorted array, if we try to index into it and press dot, you'll see that we only see a name property because entities only have names, and so sort of part of the story got lost here, right? Because really what the sort function returns is an array of exactly the same types. Now, this is where one of our latest features in TypeScript comes to the rescue, namely generics. So I could change my definition here to be a generic function. I could say that sort by name is a thing that takes a T array and returns a T array. And now, if we go down here and say sorted sub-0 dot, you'll see that we now have, whoops, did I get that wrong? Oh, I didn't type it right. You'll see that we now get ID, name, and price. So the type has traveled through our sort by name function, but now we have another problem. Oh, thank you. Now we have another problem, though, which is that it says property name does not exist on type object, and that's because we could pass anything. T could be anything here. There are no constraints on T. So we kind of need to constrain T, which we can do. We can say T extends entity. And now you'll see that the error goes away. Thank you. And indeed, if I say x dot, you'll see that it now has a name property. So now we sort of get the best of all worlds. And the thing that's interesting about this, again, if you look at the output, nothing changed in the output. It's not like there's, oh, generics, that must be expensive, you know, or whatever. No, it's the same code. However, generics add a new level of expressiveness to the type system because they allow you to express the flow of types. Like a T comes in and then something of T goes out the other side, or a callback that takes a T and so forth. And so it just adds richness, but it's only at development time. There's no cost here. We could try to change this one actually to be a little more general purpose. How about a sort function that can sort anything and then, you know, with a callback where you pick out the field that you want to sort on, for example. So let's try to go back here and grab another version of sort by, and let me try to paste that in. Here we now have a sort by function that takes a T array, and then it takes a callback that presents a T, and you're supposed to pick out whatever property you want to sort on, and then it returns in turn a T array. Now, let's try to call it down here. So we'll say sort by, and we'll sort products. Oops, comma, and then we'll write a little callback, and we'll write our callback as a lambda function, actually. So I'll say x dot, and now you'll see that we actually get statement completion here. So the type has flowed. We've inferred, we've matched up products to T array, and we figured out that T is an entity, and then we flowed the T into the callback, and now X is of type entity, and we can just pick out name here, for example. You'll note in the, I guess my playground stopped generating code here. Let me try to refresh my playground here. Something got a little unhappy. Wow, something got very unhappy. Oh, no, here we go. There we go. Okay. Now, this feature I used here, a little fat arrow, is a feature that is proposed for ECMAScript 6. They call it arrow functions. In C# we call them lambdas. I think they're in Java now as well. And you'll see that we actually compile it into a function, but we allow you to use the succinct syntax here that you sort of know from C# or Link, for example. This is almost like a little mini Link, actually. Let's try to run it, and we'll see that yes, we're sorting by name. But now we could go in here and modify and say price instead, for example. Oops. like so, and try and run. And now you'll see that they all come out in increasing order by price instead. Thank you. Okay, so that's a little bit of the sort of the power that generics bring to the table. But again, you know, the real key to remember here is that it doesn't add cost. It doesn't add runtime cost to use these things. It just gives us more accuracy in our modeling of the type system. Now, you saw me earlier here, you know, that I got statement completion on a dot. For example, if I say a dot here, and you'll see that there's a slice method that takes a number and an end and returns blah, blah, blah. And you're going to wonder, well, where did that come from? Well, the cool thing is that we can actually navigate to its definition. So I can just go here and then press F12 and go to the definition of these functions that are on the array type. This jumps me into a file called lib.d.ts. And this file contains 8,000 or 9,000 lines of declarations that model the entire JavaScript runtime library and the entire HTML5 DOM. These are the 8,000 or 9,000 lines that you're supposed to know by heart when you're writing JavaScript code. But we've written them down for you, and now we can serve them up, you know, whenever they're handy. Now you'll note here that we've declared array to be an interface, and we've declared it to be a generic interface over T, and then we've modeled all of the methods that are present on array, including here you see the slice method, and you saw some of the other methods like the sort method that I was using that takes a compare function, etc., etc. There's actually a whole bunch of stuff in here. Here's like the JSON object that I was using earlier. I can go to well, its definition is right here. So stringify, etc., etc., etc. And as I said, the entire DOM is in here. And the cool thing is that it isn't just us who can write these files. Anyone can write these files. And you can write them for JavaScript that already exists, and then simply include it in your compilation, and then magically type information is present. So typing is optional and as gradual as you want it to be in TypeScript. And indeed, one of the things that really sort of warmed my heart after we went public with TypeScript was to see the open source community pick up on this. And there's an open source site out there called Definitely Type that has now collected about 200 typings for 90% of the top 20 JavaScript frameworks are covered. And so basically, that's sort of like a smorgasbord of strongly typed declaration files for JavaScript libraries. And these are all written after the fact. So there's nothing to say that you must write in TypeScript to get the benefits of TypeScript. You can retrofit types on top of existing JavaScript frameworks. OK. I think next I'm going to try to show you, go back to, actually, if I can go back to the slides, just for one slide. And let me just sort of summarize here briefly that as you see, the type system, really, the type system is an accurate static representation of the dynamic type system that already exists in JavaScript. You saw how, in practice, we do a lot of type inference, and in reality, you don't actually have to write a lot of type annotations to get all of this machinery to work. You saw how in TypeScript 0.9, we've introduced generics that increase the fidelity of the types you can write. You saw how we work with existing JavaScript libraries. And finally, I think this is, at least for me as a language designer, and it's been an interesting exercise to work on a type system that's there for tooling's sake. This is not a type system that provides hard guarantees about correctness of your code, because at any point, you can declare a variable be any and sort of defeat the whole type system at will. However, even optional and gradual typing can provide tremendous value when it comes to authoring, verifying code. And so that has sort of been a very interesting lesson to learn. OK, let's try to go back to my demo machine here. And what I'm going to try to do next is, go back to the playground, and then let's try to, this time, look a little bit at some of the extensions that we offer, like classes and modules in particular. I'm going to try and write some code that introduces a class point here. And now you can follow along with the generated code over on the right-hand side. I'm going to declare two fields, x and y. You'll note that they don't actually generate. These are just declarations. They don't generate any code. Now I can say var p equals new point, like so. And then as I type p.x, I get statement completion here, p.y equals 20, and so on. So here I have a little point class. And you see the code that we spit out is sort of your typical idiomatic JavaScript. We put the constructor function in a function closure, and then we just return that out. Now, I might, for example, want to pass some arguments to my constructor here. And if I try to do that, well, the type checker kicks in and starts complaining that, this doesn't match my constructor, because if I don't write one, all I can do is pass no parameters. But I could go write a constructor. So we could say constructor of x colon number, comma y colon number, like so. And then in here we could say this dot x equals x, and this dot y equals y, for example. And now you see that we place the statements of the constructor in the generated constructor function over here. Now, this syntax for classes is not a syntax that we've just sort of pulled out of thin air. This is actually the syntax that ECMAScript 6 is proposing for the next version of ECMAScript and JavaScript. And so in a sense, you can think of TypeScript as a preview of ECMAScript 6 with optional static typing on top. Now, I can, of course, also write methods. Here I might want to write a distance method where I say return math.square root. And again, you saw the statement completion there, and you even see, like, we can even offer you up, like based on doc comments, little help on what these things do. So here we'll return this dot x times this dot x plus this dot y times this dot y, like so. And now, if I go down here and say p dot, you'll see that there's now a dist method that returns number. So if I dot on that, you'll see that, yep, I have a number. We also, and in the generated code, I should say, you'll note that we put the methods on the prototype of the constructor function, and this is sort of the standard way to do prototypical inheritance in JavaScript. And as you can see, the generated code now starts to become a little more involved, and this is why class-based programming in JavaScript isn't always easy, right? Because you have to sort of fiddle with prototypes and whatever. It's very powerful, but it's also very easy to go wrong. Now, we support static members, so I can say static origin equals new point of 0, 0, for example. And over here now in the generated code, you see that we put we put instance variables on the instance, we put methods on the prototype, we put static members on the constructor function, and now down here I can say point dot, and you'll see that there's now an origin member on our constructor function dot x, etc., etc. We also support private members. Let's say I'm going to declare a private color of type string, and then in here, when I am inside the class, I say this dot, we'll see there's a color equals, and I can initialize it to red here, for example. But when I'm outside the class and I say p dot, there is no color member. So private basically restricts access to being inside the class. However, if you look at the generated code, you go, well, what do you mean private? This ain't private. I mean, there's a color property on this object just like all the other properties. And yes, that's true. And indeed, this is JavaScript. You can put any property you want on any object, right? And we can't keep you from doing it. However, if you tell us that you want this to be private, then at development time, we can validate that you don't mess with these properties that you said are supposed to be private. Now, if some of the proposed features for ECMAScript 6 end up coming to fruition, such as private names, then we might actually be able to generate code that truly makes these things private. But so far, this is sort of the best effort that we could do. I was going to show another thing. You saw that this pattern of declaring some instance variables and then initializing the instance variables in a constructor is very, very common. And we actually have sort of a nice little feature that automates it all. You can put a public or private modifier on a constructor argument, and that automatically creates a property of the same name as the argument and initializes that property with the value that you pass to the constructor. So that comes in pretty handy. We also allow you to give parameters default values, not just on constructors, but on functions in general. So I could say the default value for this argument is 0. Actually, you'll see now that it complains about the other argument because you can't have a non-defaulted argument after a defaulted one. So now we've got to put one on this guy too. And you'll note that in the generated code, we now inject a test for undefined and then put the default value on the argument. And also, this allows us now to not specify the arguments on the constructor without getting complained at. Okay, so that's classes. Let me show inheritance. That's obviously an important part of classes. Let's try to declare a class point 3D, extends point, like so. And then let's maybe just pause here for a second and look at what happened in the generated code. So here's point 3D, which is now, again, we have a function closure. Now we call a helper call extends, and then we inject this helper at the beginning of your source file. This is the only time that TypeScript will inject code into your source file that you didn't write. And we just inject this simply because, I mean, we could have put it in line, but it just blows up the generated code, so it's more efficient to inject it this manner. But other than that, TypeScript doesn't have its own runtime library, doesn't try to like make you write your JavaScript code differently. It is simply just JavaScript's runtime library. Okay, in here we can then go ahead and declare a constructor that takes x and y and public z, for example. And then, we can do whatever we want to do in our constructor. But we might want to call super of x comma y. And, And here we can just sort of look at briefly what happens here. You see how we call underbar super.call and then initialize the z property. And here, again, just lots of mechanics that you have to get right when you're writing class-based programming in JavaScript, but we sort of get it right for you. Okay, let me try another little example here. Grab my tracker class here. And let me try to paste that in. Here's a little class that I call tracker, and it just has an instance variable count and a start method. And in the start method, we grab the onMouseMove event and install an event handler that increments the count and logs the number of times that the event has occurred. Now, if we try to run it, and if we bring up the F12 tools, go to the console, we'll see that something isn't right. We're just getting a bunch of nans. Now, here we've gotten bitten by, how many of you have gotten bitten by having the wrong this pointer in JavaScript? Yeah, lots. Happens with regularity. It's with regularity enough that in ECMAScript 6, these new arrow functions that I talked about earlier will repair this broken this pointer problem. Notice what happens if I change this into a lambda. Now, what gets emitted over here is code that captures the outer this and then uses it inside the event handler. I'm sure you've all written this, that equals this and that dot instead of this dot and so forth. This is sort of the formalized way to do that. It's called lexically scoped this, and it's a feature of Lambda functions in ECMAScript 6. And you'll note that we can actually generate the equivalent code that works in ECMAScript 3 or ECMAScript 5. So again, we're sort of a preview of ECMAScript 6 that works today, as opposed to in well, who knows how many years it'll be before, you know, there's enough ECMAScript 6 out there that you can start directly targeting it. It's kind of interesting, by the way, that you'll note that in here we reference this dot. But if I look at the generated code and notice what happens if I backspace here, then the capture goes away because I'm no longer referencing this in the Lambda. So we only inject this code if you actually reference this. Otherwise, there's no cost. Okay. Let me show you another thing, which is modules. Let me try to surround this with a module declaration. So we'll say module utils, open curly. We'll just indent all of this and put it inside a module. So what I've done now is I've declared a module named utils, and then I moved code, and I can move anything I want inside a module. And a module creates a function closure that executes once, and then that gives you guaranteed privacy of variables in the module. And then you can export things out of the module. So you can say export class tracker, and you'll note that when I do that, we generate a property called tracker on the module object. And now from the outside, I can say new utils dot, and then you'll see that there's a tracker here that I can new up. So modules are key for, you know, large apps, modular development, allowing you to sort of control visibility of stuff. We allow them to nest, so I could actually say module acme, dot stuff dot utils, for example. And now down here, you'll note that the function closures just sort of march off the screen there. But now here I could say new acme dot stuff. Wow, I think my browser needs to be refreshed here. Dot utils dot tracker. There we go. Now, if these names get too long, you can create an import alias. So you can say import u equals acme.stuff.utils, for example. And now here, I can just say new u.tracker. And if you look at the generated code, you'll see that that's just basically a variable that we inject. But we understand the types as well. So we understand that the aliases, the types in that namespace. And so there's sort of this interesting synergy of types and variables going on that you don't actually even have to understand necessarily, but it's kind of interesting to see how it all plays together. Okay, so what I showed you here are what we call internal modules. Another very popular form of modules in JavaScript is external modules. In fact, in particular, like systems like Node.js depend entirely on what we call external modules, or they call common JS modules. And I'll show you now how easy it is to write Node apps with TypeScript and how well we support that type of module. So let me close this stuff out. In fact, let's just close the whole thing out. And then let's say here we will open a file called server.ts. So we're just going to get ourselves a blank file called server.ts. And now we're going to write a little Node module in here. So first, what I'm going to do is I'm going to reference all the type declarations for Node. So someone, in this case us, but could have been anyone, has written down all the static types for all the Node modules and put them in a declaration file. That's the convention.d.ts. And once we have referenced that file, we now have static type information for all of the stuff that Node defines. So I can say import HTTP equals require of HTTP. And now I've imported the HTTP module, and now I can say export function, create server, port : number, comma, message : string. I'm going to create myself a very simple little server. And in here, what I'm going to do is I'm going to say HTTP dot, and now you see that I get statement completion on Node. So I'm going to say HTTP dot and call its create server method. That thing, in turn, takes a callback that gives me a request and a response. So I can write request, response, and use a lambda here, like that. And now I'm good to put code in here. And you'll note that we float the types as well. If I say request dot, it knows what those types are because we can relate, because create server gives me an http.server request, then we can get that guy, the type HTTP server request, and then flow the types in and just keep helping you all the way in. Let's try to get rid of that, and then I got a couple of lines here that I'm just going to paste in. And then we're going to start our server just by calling the listen method on the port that the user gave us when he called. And so, super simple little module. Now let me write a second module that uses this module. Here, I'll just open another blank file called hello.ts. And what I'm going to do in here now is I'm going to import the module that I just wrote. So I'm going to say import server equals require of /server. There. And now I get an alias for the module that I just wrote. So now I can say server dot, and now you see I get statement completion on the code that I just wrote in the other file. So here I'm supposed to give it a port and a message, so I'll give it a port and the message hello build, like that. And then we'll just put something on the console, say console.log of listening on 1337. There, done. So those are my two modules. Let's go to the directory where I put them. You'll see that they are all right here. Now we're going to compile hello.ts. And the compiler will automatically compile everything it needs to. Because hello.ts imported server.ts, the compiler will also compile that file. And if we look at what got produced here, we have two JavaScript files, hello.js and server. So let's try to look at type server.js. And you'll see that the compiled output is almost the same as what I wrote, except the types have been erased and an exports.createServer has been inserted. And if we type the hello.js file, you'll see that it's pretty much the same again. Now we can start up Node on hello. There. And now let's go to the browser. Go to, we can just do it right here. Localhost. :1337, and there we go. Hello build, little server works. So that's how easy it is to write code with TypeScript. Okay, if I can get my, well, you know what? I'm not going to summarize that on the slides. Let me just go. I see we're running out of time here. Let me show you one other sample, at least. There's so much stuff to show. One of the demos that we ship with is a little. Let's try to run it here. We'll compile warship, and then we'll start default.html. And it's a little battleships app where you move the ships and then you start shooting. And let's see if we can hit a ship. There we go. There's something. Let's see if we can sink it. There we go. Sunk his ship. Okay, so this little app is pretty trivial, obviously, but it's kind of interesting to look at how it's put together. It uses, as you can see up here, jQuery and jQuery UI. Now, these files provide all the static type information for jQuery and jQuery UI. So if I say $, open paren, you'll see the 7 overloads of $ that jQuery defines. We can pick one of them like $ of div dot, and then you'll see all of the things that are available here. We could, for example, pick the add class method. Now, if we look at its definition, so I press F12 on that, it jumps me into jQuery.d.ts, and you see that I'm in the interface jQuery where we've defined the add class methods. Now, a thing that happens often in JavaScript is a thing that people call monkey patching, where you impose new properties on top of existing stuff. For example, jQuery UI adds new properties to the jQuery object. So if you reference jQuery UI, you get additional functionality on the $ object. Now, we, of course, wanted a way to model that. So And I'll show you how that works. If I now say $.draggable, for example, and pick that guy and go to its definition, you'll see that I end up in jQuery.UI.d.ts, and it has defined the same interface called jQuery. In TypeScript, interfaces are open-ended, and so any file can add methods to any interface, and that's how we model the ability for things to extend each other. So you can basically, if you include jQuery UI, then you have extra methods in your interface, and if you don't, you don't. And that's basically sort of the static version of what happens dynamically at runtime. Okay, final thing I'm going to try and show is a really large piece of code, which is the TypeScript compiler itself. It's all written in TypeScript. I'm going to try to just open one of the files, ts source compiler. There we go. And I'm going to pick tsc.ts. The TypeScript compiler is about 60,000 lines of TypeScript. This is actually both the compiler and the language service. I just wanted to show you one of the interesting things, which is that we can automatically infer projects just from the comments that are in your code. You'll see here that I opened just one file that I grabbed out of the directory. Now this file in turn references other files, including this file called TypeScript.ts. And if we open up that file, you'll see that it in turn references a whole bunch of other files. And when you compile with TypeScript, we traverse all of those references and include all of those files in the compilation and also in the space that sort of makes up your world. And we can actually reflect that even in the IDE. So here you see that just by opening one file, we traversed all of that and found all of the other files and inferred what your entire project is. So you can just sort of jump in anywhere you want, and there's your entire project. Thank you. Thanks. Okay, we're getting down to the end here. Let me have my slides back, and then I'll just try to summarize quickly. We talked about classes and modules. I'm going to skip that. TypeScript 0.9 we released, like I said, last week. You saw some of the features here, generics. There are bunches of other cool new features in 09, and I would urge you to go download it, experiment with it. We'd love to get your feedback on our forums and so forth. I wanted to talk a little bit about the adoption that we've seen of TypeScript so far. One of the things that's been really interesting is to see that the HTML5 gaming community has picked up on TypeScript. I think in part because there were a lot of ActionScript Flash games out there, and ActionScript and TypeScript sort of remind they're similar. And so we've seen in the last 8 months Starling and Turbulence are two HTML5 gaming frameworks in the open source community. Bing is becoming a big user of TypeScript. The Friends Pictures app on Bing is all written in TypeScript, and more is coming online every day. We see lots of enterprise apps or websites in the open, like Zoot.io is an Azure storage management portal. Hidahem is a home finder website in Sweden. There's a graph framework, an open source graph framework called Helios.js, which actually is written in TypeScript, but people don't even know that it's written in TypeScript because they just take the compiled JavaScript minified, and that's what they give to people, and you can't really tell the difference. At the end of the day, TypeScript is just a development thing. The Azure mobile web portal uses TypeScript for its editor. In fact, we have a team in Switzerland that builds that little editor that you saw me use in the TypeScript playground, and that thing is now being used in a variety of other portals around the web. Tomorrow, you'll see Adobe make a very interesting announcement of a TypeScript application in our keynote tomorrow, so check that out. And also, last but not least, the new Xbox Music app is written in TypeScript, and to show that, I have with me here Dan Rogers from the Xbox Music team that I want to invite up on the stage and have him give you just a quick view of what that app does. So come on up, Dan.
Thank you. So my name is Dan Rogers. I'm a developer on the Xbox Music team. So When we decided to go ahead and make a streamlined version of Xbox Music, we went ahead and TypeScript helped us get there and create that for Windows 8.1. So what I want to show you is the new version of Xbox Music powered by TypeScript.
Get his screen up.
Yep, we can do a demo. All right, so I'm going to go ahead and launch the application. What you'll notice is it launches very quickly, and I'm right in my music collection. I can go ahead and customize my music collection however I like. I can customize it by artist. I can customize it by tracks or by albums. I can group it by genre. Or I can jump right into a marketplace and explore whatever new music. I can free stream any of this music. I can download it to play offline before hopping on the bus, or I can purchase it if I want to keep it. So let's look at today's top albums. So let's look at the #1 album for today. So here we'll see the details for that album. We can go ahead and select a track. We can see the WinJS 2.0 app bar here, and I can add one of these tracks straight to one of my playlists. There's a notification saying it was added successfully. I can tap the notifications, jump me right into the playlist. I can go down and I can find the new track that was added to my playlist, and I can quickly, with just a swipe, start moving that around and get my playlist ordered just the way I want it. Finally, I'd like to demo radio. So we can easily go in and create a radio station for your favorite artist. Here you can see a couple radio stations that I already have. Let's create a new one of a new artist that I discovered that I like.
Robert.
I spelled that wrong. So it's really smart. It knows when I don't spell things correctly. So there we go. And I'll tap it like a bunch of times. And what it would do is find the top tracks for that artist. It would create a station for it, like you see these stations here, and you can just immediately start streaming those stations. So everything that I just demoed here that you saw was written in TypeScript. The Xbox Music applications on Windows and Xbox are backed by almost 500,000 lines of JavaScript. And that's between the product code and the test code. We were able to continue using that existing JavaScript and our JavaScript practices without being required to convert or rewrite anything in TypeScript. That was a huge win for us, especially to get this done in the time frame that we wanted. Overall, this experience saved us time while also helping increase perf and quality of our application. We were able to save time by taking advantage of the language's extended JavaScript syntax, the statement auto-completing, and just like single-stroke refactoring and code navigation. Also, our quality improvements were mostly around using unit testable interfaces, being able to mark functions as private, and just safe and reliable refactoring. We saw huge quality improvements there, and plus modular code structuring. So when we started this, it embarked as a pilot program, but after working with TypeScript for a while, we were fully confident that we can deliver the best version of Xbox Music now on any device, all powered by TypeScript. Thank you.
Thanks, Dan. All right, where did I put my clicker here? So one quick little slide here to sum up the ecosystem. I'll let you look at the slides afterwards. But I talked already about the sort of open source activity we've seen with the definitely typed framework. Also, a lot of tools are now supporting TypeScript out in the open source community because we make the entire compiler and the language service available. Other IDEs can actually incorporate and get the same kind of statement completion, refactoring, and so forth. And our day-to-day active development process takes place on Codeplex, our open source website. And I invite you to come visit us there, see how things are going. There's an active dialogue between the developers and the community every day. And that's pretty much the end of it. I don't know if we have much time for questions, but Steve and I will be up here. If you have questions, feel free to come up and talk to us. And go check out TypeScript. Let us know what you think. Thank you. Thank you very much.